Now for part 2 of the lofi-afaction module. Just to refresh, here are the goals of this module. A voltage-controlled, amplifier-controlled noise source, a sample and hold used for sample rate reduction, clicks and pops, wow and flutter, and some voltage-controlled oscillators to drive the effects. In part 1, I covered the wow and flutter. If you haven't seen that video, link in the description below. In this video, I'll go over how I make the VCA-controlled noise source, sample and hold, and the voltage-controlled oscillators. Let's start with the medium frequency oscillator. This VCO circuit is similar to the one I use in the Drone Squad module. It has a linear response to control voltage, and the frequency range is set by changing this capacitor here. Now, I've made this circuit a few times before, so I decided to make it on some perf board. Initially, I was going to make all the subsystems for the lofi-afaction module on perf board like this, but it ended up taking too long to build and debug, and I decided to learn how to etch my own circuit boards, as seen in the previous video. And this gets mounted about here, and at the time I thought I was going to make all the submodules small like this one. How wrong I was. And after much effort, here we have it. A VCO that outputs a triangle and square wave that operates roughly in the 6 to 12 kHz range. This will primarily be used to drive the sample and hold at useful frequencies. Next submodule is the voltage-controlled noise source and the sample and hold on the same piece of perf board. There's a lot of schematics for noise sources floating around out there. I've tried most of them, and they usually don't work. This one works. The other parts of the circuit are a voltage-controlled amplifier, right out of the datasheet for the LM13700, and a unity gain adder circuit to combine the incoming signal with the noise. The sample and hold uses the second half of the LM13700 chip. It's a fairly straightforward circuit. A rising edge on the sample input sends a current pulse into the transconductance amplifier, which passes the signal to the hold capacitor connected to this op-amp to buffer the output. This thing was an absolute bear to get working on the perf board. I missed the control voltage input connection on the VCA when assembling the board. I only noticed it after I had soldered it to the faceplate. So I had to desolder it, fix it, and resolder it to the faceplate. This time I left some longer wires so that I could debug it in place if need be. And the final submodule for this video, the one in the thumbnail, the dual voltage-controlled low-frequency oscillator. This submodule will output triangle and sine waves in the 2 to 10 second range. By this point, I had enough soldering perf boards, so I designed a single-sided PCB to be etched. I was able to fit the sine shaper and one of the oscillators onto a blank PCB, and the other oscillator onto a smaller blank I had left over from the wow and flutter. Now for those playing at home, in the software for your laser cutter, remember to mirror the layout and invert the cut so that the traces are left covered and the copper we want to remove gets uncovered by the laser. And here's the PCB. Tarnish removed with some vinegar, and into the ferric chloride it goes. It was a bit of a balancing act, but the board got covered all the way. And now to drill the holes. I don't think this would be possible without a drill press. Now to populate the sine shaper PCB with all the parts. And the oscillator PCBs. Then I cut the PCBs to shape with a Dremel tool. You want to do this outside if you don't have good air filtration. Now using some right angle pin header, the oscillator PCBs were mounted to the sine shaper. I think I will mount this about here. Now to add the connecting wires to the pots and jacks and connect everything to the PCB. And this is when I found out that it didn't work. Turns out that running this oscillator at low frequencies makes it very sensitive to output impedance, and the input impedance of the sine shaper was too low and the oscillators would stall. Now the fix for this is simple. A unity gain follower op-amp circuit between the oscillator and the sine shaper. To add this circuit to the already finished PCB, I used the flying chip socket technique. I soldered all the wires I needed to the chip socket and covered it with my favorite dielectric stay put, hot glue. Then it was only a matter of scraping a break in the traces for the sine shaper circuit and soldering the leads, connecting the chip socket, and with that done, installing the chip. And there we have it, an ugly triangle wave and an almost sine wave. This was any other module, I'd be tweaking component values to get a perfect triangle and sine waves. But this is for a lo-fi module, so I'm going to roll with it. Now let's see what it does to some sound. Get it patched up. And here's the sound with no noise added, the sample rate all the way up, and no wow effect. Now let's start adding some effects. So some final thoughts. Running the sample and hold at lower frequencies, a high-pitched whine can be heard. This needs to be filtered out. And I'm not feeling the need for clicks and pop circuit anymore. So stay tuned for part 3, where I add high-pass and low-pass voltage-controlled filters, and I think we will have us a completed module prototype. Thanks for watching.